That's where Dexon comes in. So we want to solve the problem of scalability and cost. So on your left, you see the traditional blockchain like Bitcoin and Ethereum. They both have similar structure. Each block of Bitcoin and Ethereum relies on some information from the last block. So you have to include the hash of the previous block into your block, and then you start recording the new transactions in your block. This entire process is serial. You can hardly make it faster. There are different approaches. You can make the blocks produced more frequently, or you can increase the size of each block. But in the end, they are just short-term solutions. They are not actually solving the problem. In Dexon, instead of one chain, we add parallelism into the system. So instead of one chain, we have multiple chains running at the same time. So each vertical line is a blockchain. And the person or the party producing these blockchain, we call it a validator. So each validator is proposing blocks, and at the same time, they observe the blocks proposed by other validators and verify for them. So, and that's depicted as an edge in the graph. For example, this node here, this validator has observed this block somewhere at this time, and then it checks the content it carries. And if it's okay, the next block produces will have the information to act this block. It basically means that I have observed this block and it looks good to me. With this mechanism, different validators can propose block simultaneously and while verifying for each other. So I'm not going to go into too deep of the details. If you're interested in how the algorithm works, we have our paper on our website. It's dexon.org. Basically, each validator proposes blocks, and when it proposes blocks, it broadcasts the blocks to other validators. So other validators, after a while, will see the block. And if they see the block and then check that looks good, it will include the acting information in its block. And then the next step, all the blocks that has accumulated enough of these acts, enough of these acknowledgements, can go into the second stage. They have to gather more than 2/3 of the acknowledgements of the number of nodes in the system. And then these blocks are processed and created a total ordering of these blocks. Why is total ordering important? Because only with total ordering, we can add more sophisticated, more complicated applications onto it. So, like, if we want to support smart contracts, some of the smart contracts will rely on the total order. Like, which transaction comes first will have an effect on the final state of the contract, right? So order matters. A lot of other blockchains or like Tango and IOTA, they provide these scalability, they provide these parallelism, but in the process, a lot of them trade off this possibility to be total ordered. So maybe a transaction can happen here, and then another transaction happens here. It's hard for these kind of networks to decide which one actually comes first. That will limit the use cases. The final stage is timestamp. In some use cases, timestamp matters, like in a case of an ICO contract. The logic could be something like the ICO ends at some date, so if you transfer your money after that date, the purchase is not valid. Timestamp matters, and this timestamp in our system is generated from consensus. It's not from the block producers themselves, because they can be lying, they can be stamping very early time or very late time to like temper the outcome. There's our paper on the website, so if you're interested, you can check out dexon.org. But from a very high point of view, I just want to compare Dexon with other networks to show you why Dexon is efficient. In the most traditional blockchain system that runs on proof of work and longest chain like Bitcoin and Ethereum. Red area is the energy wasted, and the green area is the energy actually goes into ledger keeping, because that's what these blockchains are about, right? The purpose of them is to keep the ledger. Keep the record of who transacted, keep a record of who transacted how much money to someone. So actually, this is the only part that's actually beneficial to the world, and all the other red area is wasted. And in a scalable system like IOTA, a lot of the energy still goes into the proof of work part, but the good thing about that is that it can, multiple nodes can propose, that can record transactions simultaneously at the same time, so that makes the entire network scalable. The newer system like EOS, it uses proof of stake and PBFT, so basically only the supernode at any time is proposing the block, and it proposes the broadcast to the chain, and other people are just there to verify that. So the gray area is the energy that are not used, the computational power that's not used. Only one supernode is proposing block at any time, and the other nodes are just there to verify. In Dexon, all the nodes are proposing blocks, that are recording transactions at the same time. Also, we minimize the communication cost in the system. So basically, the green area is the total output of the system, which is pretty good. So in comparison, Dexon can produce more than 1 million transactions per second, and with less than 1 second of confirmation time. And the transaction fee is negligible. One thing to note that in EOS, currently it doesn't really do BA on the blocks yet, the Byzantine agreement on the blocks yet. They will add it soon. And when they do, the latency can be reduced to a matter of seconds. But right now, they still have to wait for the nodes to connect after the proposed block. And when enough of the blocks have connected to the block, and then it becomes irreversible. That's our purpose, is to bridge the chasm in the ecosystem, and then we can move forward to the next stage of adoption of blockchain. And so I don't have time for this, and thank you.